Welcome to fourth grade math night. Thank you for joining us to learn some information about what your child is going to be learning in math for the remainder of this year. If you have any questions about the information that I go over in this slideshow, please feel free to message your teacher or your child's teacher to ask questions if there are strategies that maybe you don't understand, or maybe you want to know more about a little bit more about math and what we will be doing in math. So the first thing I would like to go over with you is like upcoming concepts that we will be doing the remainder of the year. We will be moving into multiplication next week. And this will go up to a 3-digit number by 1 digit, and then it will also be 2-digit number by 2-digit number. So they will not go above the hundreds place value when they are multiplying. They will be doing that in 5th grade. They will go above a 3-digit number in multiplication in 5th grade. For division, it is the same. It's 3 digits by 1 digit, and it also will include remainders. We will be doing fractions, including mixed numbers. We will focus on, a main focus will be equivalent fractions and how to find equivalent fractions. And in finding equivalent fractions, that will help them to compare and order, and then also add, subtract. And we will also be multiplying by a whole number. So we will have a fraction by a whole number. We will not be multiplying a fraction by a fraction. That will also come next year in 5th grade. Then we will go to decimals. We will be comparing and ordering decimals. And then we will also compare fractions and decimals to the tenths and hundredths. We will look at measurement. We will be looking at the metric system and conversions. And then a big concept that we start working on in 4th grade that will continue throughout their school years is working with word problems that are multi-step. We have noticed that so far this year, as we are working on 2-step word problems, that the students do fairly well with the very first step. And they can get the correct answer for the first step, and then they kind of forget about the second step. So we do work on those throughout the year. So we've already worked with some of those 2-step word problems. So we will just input that throughout the year, and that will be with all 4 operations. And they will have some word problems that may mix up addition and then multiplication, or subtraction and then multiplication. So if you could work on some of these multi-step problems at home, that would probably really be good for them to get more practice. And then we will be going over geometry, and that will focus on angles, lines, polygons, and symmetry. We have already had our quarter 1 check-in. We will be going to our second quarter check-in in January. So this will be after we come back from the holidays. So the North Carolina check-in is what replaces those old benchmarks that we used to have from the county. So you probably hear the term benchmarks. We now call it North Carolina check-in, and this test comes from the state, and it is closely aligned with the EOG, so it's almost identical to the EOG, except it's about half of what they will do on the EOG, and it focuses on 1 quarter at a time. So everything that we cover in quarter 1 will then be tested for quarter 1 check-in. So for check-in 2, it will be everything that we covered for quarter 2. This is a time test. They do get 90 minutes. They are allowed to have extra time, but the goal is that it is supposed to be completed in 90 minutes for the average student. There are some open-ended questions where they will not have multiple choices to choose from. They will have to solve the problem, and whatever answer they get is what they will plug in. This is taken on the computer. The check-ins are about 25 questions, and then you normally can double that, and that's what you can expect for the EOG. And then teachers do receive data, so we do take this data and we form groups, and we do review some of the concepts that maybe were most missed, and go over this material multiple times so that by the time EOGs get here, hopefully they will feel more confident and have the ability to do much better on those concepts that maybe they missed on a check-in. So with word problems, we do give strategies for students to use, such as the cube strategy. So this strategy helps students organize information within word problems. So if you look on our little anchor chart that we have here, you see that cube stands for different things. So the C would stand for circle key numbers and units. So what do I know? And I do tell students to be careful with just circling every number. We do talk about information that is not needed in a word problem or that they can eliminate. The U stands for you underline the question and make sure that they know what the word problem is asking of them so that they know exactly what they are being asked to do so they know what to do to solve it. B is boxing those math action words and also them figuring out, am I having to subtract? Am I having to add, multiply, or divide? Or am I doing two different steps? E is evaluate and eliminate. This is what steps do I take to answer the question and what do I not need? What information can I get rid of? And then S is for show your work and check. And this is the one part that I see a lot of students skip, especially on a check-in, is they will get an answer, they'll work it out, they'll spend time working out the answer, but they very rarely use a different strategy to check their work. And we like to tell students that they can use a different strategy to check their work so they're not doing the same exact work that they just did. So this is the one step that could be very beneficial to catch careless mistakes. So if you want to reiterate to your child when they are working in class or they are taking a check-in, just to double check their work so that they can check for careless mistakes. All right, time. So this kind of goes along with what we're saying about time. It is so important that kids take time in math. A lot of students really like math and they feel confident in math. They like to do stuff in their head and they do it very quickly. It's so important, number one, that they're showing their work. Some students can do it in their head. We know that they can do it in their head, but it's also very easy to make careless mistakes just doing work in their head. And then also for their teacher, if they do make a careless mistake, it's very hard for us to know where they're going wrong if we don't see their work on their paper so that we can actually find the exact step where they messed up. And so showing their work does take time. And some students don't want to give that time. So make sure that you are, when your child is bringing home their work, that you're looking at their math papers and that you're actually seeing that they are working these problems out, no matter what kind of problem it is. It could just be a straight computation problem or it could be a word problem. Just check to make sure that your child is showing their work and that they're carefully reading questions and showing their thoughts and underlining their important information. I like to tell students that in reading, we show our thinking, and that also serves for math. They could show their thinking with a math problem and what they need to do and making sure if they're seeing a clue word that helps them to think, oh, I need to multiply, that they're writing that they're showing that thinking. So for strategies for multiplication, so strategies today are not like it was when we all were in school. It looks very different. It is very different. And to a lot of people where we didn't use these strategies in school, it is very confusing. So here's an example of some of the strategies that we use for multiplication. If I know for myself that, and this is Ms. Keller speaking. I don't think I introduced myself at the beginning of the video, but I use the standard algorithm, and I'm sure a lot of us used the standard algorithm when we were in school. We will go to the standard algorithm, but we're going to go to that towards probably around April. So not at the very end of the year, but towards the end of the year. So we do give them some other strategies as they're learning to multiply multi-digit numbers that helps them break numbers apart and helps it to be a little easier with multiplication, especially if they are still having trouble with their multiplication facts. So we do break it into an easier problem. So we would take 17 times 22 If you look on the right, you will see an area model or an array model, or you could also hear it called the box method. Really, this is the distributive property. We're just breaking those numbers apart. So we're breaking 17 into 10 and 7, and then we're breaking 22 into 20 and 2. And so each box, so the top left corner, we did 10 times 2, or 10 times 20, I'm sorry, and that's 200. And then we did the top right box, which would be 10 times 2, that's 20. Then we went with the bottom number, so that's on the left, so that's 7, with the top 20, so 7 times 20 is 140, and then 7 times 2 would be 14 in that lower right-hand box. We do work a lot with powers of 10, so we try to tell students that if they know what 1 times 2 is, then they can tell us what 10 times 20 is. Because of the powers of 10, we know to place the zeros that are in our equation also in our answer. And then what we do is in all 4 of those boxes, we take the product. For each of the boxes, we add each product up, and then that would give us our total product for 17 times 22, which would be 374. The right side of your screen that shows this strategy is the main one that students like to use versus the left side. And the left side is really the same thing. It's just without using that box. They're choosing one number, and they're breaking that 22 up into 10 and another 10 times 17 and then a 2 times 17. And they're taking those 3 products and adding those up, and they should get the correct product. And this is where I was talking about when students check their work. If they could kind of get a couple of strategies under their belt, they could do multiple strategies to then check their multiplication to make sure that they have the correct product. All right, so here's a problem that you could try on your own. If you want to pause the video, you can try doing the distributive property method, which is also called the array method or the box method. And so I've given you 35 times 27. So if you would like to pause the video, you may work this problem out using that strategy that you are probably not used to solving, and see if you get the correct answer. Okay, so the problem that was 35 times 27, if you got 945, then you are correct. Way to go. Good job. I hope that you feel confident using that strategy. And our students will be starting this next week, so I'm sure you will be seeing this come home, or they will be talking about it. So this slide is to say, why do you not teach the old way? Because that's a question we get. Like I said before, we will teach the standard algorithm, which is the normal way. That's the most common way that we multiply in the United States. That's what the standard algorithm stands for. So for us, it seems quicker. Trust me, as a teacher, I completely understand that. It is quicker for us because that's what we were taught. But when we were in school and were taught the standard algorithm, we practiced and practiced and practiced, and I can remember doing about 30 to 50 problems a night. In 4th grade, we will build this understanding towards the end of the year, and we will show the old way. But the way that the different strategies that we're teaching kind of give them a deeper understanding of what multiplication is, and it makes them know what they're actually doing when they're multiplying versus, okay, I'm just going to do this same step over and over and over, which is what we were taught years ago. We were just taught the steps to do it and not really the basic understanding of what multiplication is. What are we actually doing? What is the purpose? Okay, and so here's some strategies for division. So one strategy is that they can turn it into a multiplication problem. So if it's 477 divided by 9, we could start with easier numbers to multiply. So we could do 9 times 50. And then we could do 9 times 3. Okay, so 9 times 50 gives us 450, so we're really close to 477. So then we could do 9 times 3, which would give us 27, which would get us right at 427. And then we would add up, we would add the 50 and the 3, and that would give us 53, would be our quotient. If you look at the right side, this is called the sevens method because it looks like a 7, and you could also relate it to the game Hangman, where you're trying to figure out a word that somebody's spelling or a sentence. So it looks very similar. And so what you're doing is you're trying to get landmark numbers that are kind of easy to multiply to get close to 477. So like if the students know 9 times 5, then they know 9 times 50 is 450. And so what they're trying to do is go from 477 and get it all the way down to 0 or less than 9. And so they know if they have less than 9, then that is their remainder. So here's a problem that you could try: 327 divided by 8. So if you would like to try one of those strategies that I just talked about, feel free to do that and see if you are correct. And I would suggest doing exactly what I tell students to do is you do it the way you know how to do it, and then you could use one of the other strategies to practice it and then check to see if you're right. Because if you're using the strategy that you guys are comfortable with, which is the standard algorithm, then if you use the other strategy, you'll know if you're spot on the strategy. All right, so in division, what should your child do with remainders? Well, in equations such as 134 divided by 5 equals 26 remainder 4, students should write what is left over, but not in decimal form. So in word problems, students have to interpret the remainder. So in other words, they might have to do something different with the remainder depending on the problem. So here's an example. Mary had 134 pieces of bubble gum. She split them among her 5 friends. How many pieces did each friend get? All right, so students would have an answer of 26, but they wouldn't write the remainder 4 because that they are going to get whole pieces of candy. We're not then going to take those 4 pieces and like try to split them up between her 5 friends. So there, they would just write 26 pieces of candy is what each friend would get. Okay, so those are just some examples of what your child will be learning this year, and just a really big talk on multiplication and division, because that is the foundation. If your child is struggling with multiplication and division, and you notice that this year as we are working with it every day, please let us know. We could give extra practice for them to do at home. We could work with them at school, because multiplication and division will only expand the further they get in school. So if they can build a good foundation this year and set themselves up for success of being able to divide efficiently and being able to multiply, then that will only bring them success in the future years. So please let us know if you do have questions or you would like to meet with us for us to show you these strategies in person. I know it's a little different doing these parent nights by just watching a video. It's probably not near as exciting. But we do appreciate you watching the video, listening, and doing everything that you know to do for your child. And we really do appreciate all the support that you give us. Please let us know if you have any questions, and we hope you have a great night.